Today we're going to be doing candy on Leetcode, and the question is, there are n children standing in a line. Each child is assigned a rating value given in an integer array ratings. You are given candies to these children subjected to the following requirements. Each child must have at least one candy, so that would be the initial value. Children with higher ratings get more candies than their neighbors. Return the minimum number of candies you need to have to distribute the candies to the children. Okay, so we have an example here. Let's go through it quickly. So these are the ratings for each child in a line, and we want to figure out the minimum candies we need to distribute them, given that ratings that are higher than the neighbors get more candies than otherwise. So we can start off by giving them one each, and then we see that since 1 is higher than its neighbor 0, it must have an unequal number of candy compared to 0. So we increment it by 1 to 2, and you can make the same argument for the last child too, with a rating of 2. So he would also get a candy 2, and that's how they got this answer. So that's all fine. Let's also double check the second example. So initially we give all of them 1, and since this has a higher rating than its neighbors, it would be incremented to 2. And this is an interesting edge case, since this rating 2 is not higher than its neighbors, which is 2 and no other neighbor here. It would stay as a 1. So it's speaking strictly higher rating than its neighbors. Okay. So the approach here, well, if we look at what approach wouldn't work, if we simply started off with 1s and made comparisons, for example, if we went from left to right and saw if the previous neighbor had a lower rating, we increment. So over here, when we jump to 2, we see that 1 is less than 2, so we increment the candy count. And here we see that 2 is not greater than the previous rating, which was also 2. We do not increment. So that seems to work here, but if you apply the same logic up here, we will see that what would happen is that we would start off with a 1, and 0 is not greater than 1, so we would keep it same. However, 2 is greater than 0, so we upped it to 2. However, we didn't account for the fact that 1 is greater than 0 to begin with. So I think that would create issues. The way we would resolve that issue is we would, after going from left to right and incrementing the ratings, the candy count, we would apply the same logic in the reverse direction, and see what the minimum rating should have been given what the rating array currently is. So over here we have this this candy list, given that we have updated them from left to right for children that have higher ratings than its neighbors. So if we go from right to left, we'll see that 0 is not greater than 2, so we keep it the same. However, 1 is greater than 0. So then we have to make we have to see if the current value can be overwritten. So what we would do is we would say, is the previous rating 1 plus 1 larger than the current value? If it is, we overwrite it. So in this case it is, because 1 plus 1 is 2, and that's larger than 1, so we would overwrite it. Otherwise we could just keep it whatever it was stored as. And if that doesn't make sense, I'll show you again in the code. So this is the answer. So in the code, that would just look like we start off with our initial result, which is just, well, this is length of ratings, and the initial result would just be ones times, I guess we have to do it this way, 1 times n. Then we loop through the ratings list from left to right first. For I in range n, if I is 0, we skip. Otherwise, we check if rating of the previous index, if the current index is larger than rating if the rating of the current index is larger than the rating of the previous index, we update result of I to be result of I minus 1 plus 1, and that would just be the left to right pass. And next we would need to make a right to left pass just to check the case where the right neighbor, the left neighbor, the right neighbor has a higher value or has a smaller value. So what that would look like is for I in range or reversed range of n, if I is equal to the last index, we can skip it. Otherwise, if rating of I is larger than ratings of I plus 1, we would need to update the result of I to be equal to the maximum of whatever is currently stored versus result of I plus 1 plus 1, so higher than the right neighbor's candy count. And then we can just return sum of result. And that should be the minimum number of candies we need. So let's try it. So there's already issues that I see. So this was ratings. Okay, let's try it again. Let's submit it. Okay. So let's quickly analyze the space and time complexity. The space complexity, since we're creating a list for the result, it would just be O of n. And the time complexity, since we are looping through the ratings list 3 times. Yeah, because we have to do a forward pass, a backwards pass, and then do a sum. It would be O of 3n, but we can drop the 3, so it's O of n. So that should be good.